In terms of modules, we have one power supply module, we have two photoresistors, and we have two of these 1K resistors, as well as the stepper motor, a 9-volt battery, this stepper motor board, and our Arduino. In addition to this, I have this plastic divider, which came in my Arduino kit, and this small cardboard cutout, which is used to block the light that is hitting the right side to also hit the left side, as well as this makeshift solar panel, which does not actually receive any light, but it's just used to show how this would move. In terms of connections, we've got this ground cable, which is being supplied by this power module, connected to our 1K resistor, which is connected to our photoresistor, and connected to one of these analog pins, either A1 or A0. For me, I've got on the right one is connected to A1 and the left one is connected to A0. And then finally, this photoresistor is also connected to this 5 volts being produced by the power supply module. On our stepper motor board, you can see we have an IN1, IN2, IN3, and IN4. These are connected through male to female cables to the pins 9, 10, 11, and 12 respectively. We also have two more male to female cables which are connected to the positive and negative terminals over here and connected to our 5 volts and ground respectively. And our stepper pins, stepper pin 1, 2, 3, and 4 are connected to pins 9, 10, 11, and 12 respectively. Next, we have 3 integer values for step number, left and right. These are all set to 0 for now, however they will change later on, which is why they are not a constant integer, like our left sensor and our right sensor. These do not change throughout our tests, that's why it's set to A0 and A2. Next constant integer is our threshold value. This is set to 15, which through many tests has been what has worked for me the most. However, you will have to do your own tests to find out what would work for you, because everyone has a different lighting in the room, such as if I moved this setup to my kitchen, there would be a different threshold value, as there's more light in there than there is in my bedroom. Another integer is our position. This is our initial position, which is where the stepper motor starts off at. And then we have constant integer minimum position and maximum position. This is where it will go when it's all the way to the left, and this is where it will go when it's all the way to the right. We've also got this special function, void one step boolean, for our direction. We set this up as a boolean, as a boolean is a true or false value, and there are only 2 values for direction, which are obviously left and right, clockwise and anti-clockwise. So when it's true, it can move one way, and when it's false, it can move the other way. Next, in void setup, we have our pin modes. Stepper pin 1, 2, 3, and 4 are all outputs, as this is connected to our motor. And then we have serial begin 9600. In our void loop, we have left, which is analog read left sensor. This is basically setting a value for whatever the left sensor or photoresistor is picking up. And we have the same thing over here for our right sensor. And then here we have an integer, which is just the left minus the right, which basically gives us the difference between our left and our right photoresistors. And then over here, as you can see, it just prints this out so we can see it in the serial monitor. It prints out our left value with the word left, right value with the word right, difference with the word diff, and position with the word position. After that, we have an if statement. When our difference is larger than our threshold, this will only happen if the left side is larger than the right side, as the right side would be shown as negative. If our difference is larger than our threshold, and our position is above the minimum position. For I equals 0, this is set as an integer, and I is less than 100, as well as position being larger than minimum position, we will add 1 to our I. And this will happen until I is equal to 100, which shows our step function has 100 steps. Now every time I gets added, another value gets added, our one step function becomes false. This shows that it moves one step to the left. This then subtracts 1 from our position value. Then we have else if difference is less than negative threshold, as when it moves to the right, it becomes negative, and position is less than maximum position. Same thing over here, insert I, which is equal to 0 for now, and once it's less than 100, shows that it has 100 steps, and position is less than maximum position, we add 1 to I. But over here it says 1 step true, which shows that our stepper shifts 1 step to the right, and position gets added by 1. We've got this delay over here, which shows that if both of these statements are false, nothing happens. This is in our else statement. Next, in our void 1 step, we've got boolean and direction. This will give us a true or false value, and that true or false value will entail give us a left or a right movement per step. Over here we've got a switch case, which was given through a template. However, just to go over it really quickly, for case 0, we've got stepper pin 1 as high, the rest is low. Case 1, we've got stepper pin 2 as high, the rest is low. And this goes on and on for the first one, for the first part over here. And then we have an else, as we've got an if up here. This is if it wants to move the other way around. We start with stepper pin 4 high and the rest low, then stepper pin 3 high, the rest low, stepper pin 2 high, the rest are low, and stepper pin 1 high, the rest are low. This will make our stepper motor move in the opposite direction if this case is true. As you can see here, our switches are in terms of step number, and these step numbers come in waves of 4, from 0, 1, 2, and 3. This ties in well with our last piece of code over here. Step number plus plus, this adds 1 to our step number per step. If step number is larger than 3, obviously we only have 3 cases over here, it will set the step number back to 0. So these step numbers, they go in waves of 4, then they'll restart, go to waves of 4, and then restart. And then this will continue to go until it reaches the minimum or maximum steps. In a real life scenario, you do not want the stepper motor to be moving multiple times per second, as this would obviously counteract the workings of the solar panel, and you would spend more energy than you're getting in. So you would add in your loop over here, let's say delay, and then we would add a value. Let's say we want 20 seconds. We would add that, semicolon, and then this would delay when our photoresistors are checking for light. In real life, obviously we wouldn't have our delay as 20 seconds, we would have it as something much higher. So let's say we want to add 2000 seconds. We would put this value over here in our delay, which would tell the photoresistors to only check for light every 20,000 seconds. Over here you can see our serial monitor, which shows the values for the left and the right photoresistor, the difference between them, and the position of our motor. Now I'm shining the light onto the left photoresistor. As you can see, the left value goes up and the right value stays the same. And now I'm shining it onto the right, left, and right. You can see the position updating and changing, left and right. The reason why we're only using 2 photoresistors and there's only 1 axis of rotation is because the sun rises from the east and sets in the west, which means on a solar panel which is connected to the ground, there is no need for it to rotate towards the north and the south.